throw in here the definition for complementary and supplementary angles. This is something that you usually see in geometry, but I wanted to make sure that we remember it so that we can answer these questions in 1.1. So two angles that are complementary together, they form a 90-degree angle. And now in radians, 90 degrees is pi over 2. So these two angles added together give you pi over 2. We call them supplementary if they add up to pi. So if the two angles together give you pi or a straight line or 180 degrees, they are called supplementary. Okay, so for a quick example, let's find both the complement and the supplement of this angle 2 pi over 5. So what we're trying to find the complement, we want to think of what angle would I add to 2 pi over 5 to get pi over 2. So in equation form, this would be like 2 pi over 5 plus what angle would give me pi over 2. And so you can see that in solving that, you would just need to subtract. So we would just be subtracting our angle 2 pi over 5 from pi over 2. So to find the complement, we're simply going to subtract pi over 2 minus the angle that we're given, 2 pi over 5. Now again, with these radians, we got fractions. To add or subtract fractions, we need a common denominator. So please make sure you get a common denominator before you try to subtract. Denominators need to be the same. So a common denominator for 2 and 5 would be 10. It always works to multiply them together. It doesn't always give you the least, but it will always give you a common denominator. So here using 10, for the first fraction, we got to multiply the top and the bottom by 5. That's going to give us something over 10. And for the second fraction, we would need to multiply the top and 2. That's going to give us something over 10. So in doing that, we've got 5 pi over 10 minus 4 pi over 10. Now the denominators match, we can just subtract the numerators. Remember to treat the pi just like a variable. So 5 pi's minus 4 pi's will just leave me with 1 pi. So I've got 1 pi over 10. So that is the complement of 2 pi over 5. You can double check. If you add them together, 2 pi over 5 plus pi over 10, you should get pi over 2. Now let's do the supplement. So this time they have to add up to pi or 180 degrees. So we're just going to subtract pi minus the angle that we. And you would do the same thing with degrees. You would be subtracting from 90 degrees for a complement, from 180 degrees for a supplement. All right, so again, I need that common denominator, and this pi is just over 1. So I'm going to make the denominator 5. That's the common denominator between 1 and 5. So I'm going to multiply the top and the bottom of my first fraction by 5. So now I have 5 pi over 5 minus 2 pi over 5. Subtracting the numerators, I've got 3 pi over 5. That's the supplement to this angle, 2 pi over 5. And you can see if I add the two together, I get 5 pi over 5, which is pi, and that's what we wanted. So I mentioned that we want to be able to convert between radians and degrees and go back and forth. So to do this, we need a conversion factor, just like changing inches into feet. So we can get the conversion factor using what we know about radians and degrees. So we know that one full revolution or one full circle is 360 degrees. And we know that that is also 2 pi in radians. So 360 degrees is equivalent to 2 pi radians here. So if I were to solve this equation for either radians or degrees, I get the conversion factors. So I want to end up with radians, so I want degrees to cancel. You always want to put the units that you want to cancel in the denominator. So I want to use here my conversion factor that gives me that has degrees in the bottom. So this would be pi over 1/8. So I'm going to take 135 degrees, and I'm going to multiply it by pi over 108 degrees. So pi radians over 180 degrees. And you don't have to write radians here. I'm just trying to distinguish between the two. But you can see I've got degrees on top, degrees on the bottom. They're going to cancel each other out, which is what I want. And the only unit left would be radian. All right, so we could just multiply straight across, which will give you 135 pi over 180. And then you just need to simplify that fraction as much as you can. So looking for common factors between the two. This one looks like I could at least start with 5. They're both divisible by 5. All the way down to you get it in simplest form. If I divide by 5, 7 pi over 35, 36. And it looks like I can reduce that some more. I see common factor of 9 between those two. So dividing them both by 9, I get 3 pi over 4. So in radians, 135 degrees is 3 pi over 4. Let's do one going the other way. And let's convert negative pi over 2. Okay, so I'm starting with radians. So this time, I want degrees to be on top, not radians on the bottom. So I'm going to use 180 over pi. Okay. And then I'm going to multiply those two. So I can see those pi's are going to cancel out. The 180 and 2 can simplify to 90 degrees. And this is a negative times a positive, so it's going to stay negative. So negative 90 degrees. We know that one is negative pi over 2. I want to do one more example, just because we kind of get used to radians having pi's, and it kind of feels weird when they don't have pi. But I want you to know that if you just get a number as a radian degree measure, you can still convert it to degrees. So let's say we want 2 radians, 2 degrees. So it doesn't have a pi. Same process though. You're going to multiply your 2 radians. And I want to end up with degrees, so I'm going to put degrees on top. So I'm multiplying this by 180 degrees over pi. And I'm just going to multiply that and simplify as much as I can. So 2 times 180 is going to give me 360 degrees over pi. And if I need to simplify that, or, I want like an actual number of degrees that I could draw or estimate, then you would just divide. So using the pi button on your calculator, or if you're estimating, you can use 3.14, but we're doing 360 divided by pi. And that's going to give you approximately 114 degrees, 114.6 degrees. So even though the radians didn't have a pi, use that same process to convert it to degrees.